single phase induction motor is not self-starting. By the use of an idea called alternating uniaxial quantity, let me consider a two vectors taken as A and B. So the two vectors would be A and B. This is A vector and this is B vector. If we consider that A vector is rotating in anti-clockwise direction, B vector is rotating in clockwise direction. B, according to the principle, two oppositely rotating vector with an half magnitude is nothing but phi m by 2. The magnitude is phi m by 2 for a vector A. Magnitude for B is phi m by 2. Here the two vectors A and B are rotating in with a synchronous speed ns. The resultant of A and B vector is phi m. Which is shown here. Now coming to the figure A, the same which I drawn. A is a phi m by 2, B is phi m by 2. A is rotating in anti-clockwise direction, B is rotating in a clockwise direction. The resultant flux would be phi m. Similarly, if the A is rotating at an angle, any angle that may be a theta, that is positive theta, B with an any angle minus theta, the resultant flux would be phi m cos theta. If you see the figure B, the resultant flux would be by the use of parallelogram law. If you see figure C, here the A in anti-clockwise direction, B in clockwise direction, these two vectors are opposite to each other, that is 180 degrees phase shift. Therefore, the resultant flux phi r the resultant flux phi r is equal to 0. That is phi m by 2 minus phi m by 2. Similarly, if again the rotating vectors A and B are rotating with a different angle, that would be produces a resultant flux called minus phi m. The figure D is similar to figure A, but A is in one direction and B is in another direction. That is opposite to each other. If we see the figure E here also, the figure is as like a C with opposite mag- opposite magnitudes. That is, the resultant flux here is also 0. If we draw the fluxes what we produce from theta equal to 0 to 360 degrees, the curve would be shown here. For theta equal to 0 degrees, the resultant flux is what? Phi m. The resultant flux is phi m. So this is what? Phi m. The angle between 0 to 90 degrees, that would be phi m cos theta. So for 90 degrees, the resultant flux phi m is 0. Similarly, for negative 90 to 180 degrees, the resultant flux for 180 degrees is maximum. Similarly, for 180 to 360 degrees. So the flux at this instant is maximum and reverse negative phi m. So which is as like a cos waveform. Here we have considered that two vectors. The two vectors are A. A is in one direction. A is in one direction means rotating in a anti-clockwise direction. I'm considering that as forward flux phi f. B vector which is rotating and which is nothing but backward flux. So A vector is rotating in a clockwise direction, anti-clockwise direction, which is producing a flux called phi A. B in a clockwise direction, which is producing a flux called phi B. If there is a flux means there is a torque. So let it be the torque is Tf here. Since it is a forward, it is producing a torque called forward torque. It is torque called Tb, backward torque. The principle here is nothing but here the torque, forward torque is rotating in anti-clockwise direction. Backward torque is rotating in clockwise direction. The two vectors again here is in opposite direction. As we seen that the two vectors which is opposite to each other is nothing but the resultant torque is Tr is equal to 0. This is the concept what is behind here. I will show how the torque is resultant torque is 0. So that I will show you how the resultant torque is 0. Meanwhile, while the rotor is rotating, but by the principle of two vectors, in a forward rotating flux, the slip is S. If it is a backward rotating flux, it is producing a flux called 2 minus S. This is all because if you say uh, for a forward rotating, the slip corresponding to forward, SF is equal to Ns minus N by Ns. This is nothing but what? A slip. You know the slip definition. So this is what? S. Now the slip corresponding to backward rotating flux, which is nothing but S P. So SB is equal to again Ns minus N by Ns, right? But here N is in negative, which is reverse, right? So Ns minus of minus N, which is not, which can be written as 1 plus N by Ns. So this can be written from this equation 1 plus 1 minus S. So this is what 2 minus S. Okay. So this is what 2 minus S. Now I will show you how the net torque is 0 and how the torque will be cancelled both forward field and backward field. Uh, you know that the torque slip characteristics of a three-phase induction motor by the torque slip characteristics of a three-phase induction motor. This is the torque due to forward field and this is the torque due to backward field. If we superimpose these two, the resultant characteristics are this one. By superimposing both the characteristics, if we observe at this instant, the resultant torque is 0. The resultant torque is 0 means there is no chance to rotate by itself. Hence, the single phase induction motor is not a self-starting device. So at this instant, the rotor speed n is equal to 0. Here the torque is 0 means the n is equal to 0 and there is no chance of rotor movement. Hence, single phase induction motor is not a self-starting device. So in order to make a self-starting, uh, there are different mechanical means and electrical methods of starting also. The electrical methods of starting is not required to you, and in single phase induction motor, working principle of a single phase induction motor and the double field revolving theory